So guys, today's session is all about distributed cache with .NET microservices, and my name is Ajay. So let's proceed. So these are some etiquettes that we'll follow. So punctuality we couldn't follow, but that's fine. And feedback, we'll take it at the end. Silent mode, obviously we would be, I think, for 30 minutes. And coming to the agenda, yeah. So these are the 11 topics that we would be covering with the 1 to practical examples. So the very first thing is the introduction to caching, like then advantages. Then we will see types of cache. Then what is distributed cache, caching patterns, eviction, Redis. I mean, we have memory cache, we have Redis cache, and other types of cache. So we will see then setting up how to set it in .NET, and then implementation, a brief demo, and then we'll move to the conclusion part. So yeah, introduction to caching. Coming here, like what is caching exactly? Basically, caching is nothing but a technique to temporarily store frequently accessed data in memory for quick access. So basically, let's say if we are retrieving data from database all the time, let's say I need to retrieve some kind of record from database, I would give a database call to retrieve that data. I would maybe query something and again hit the database. So this increases my operations, right, on database load on the DB. So the idea is that the data that we retrieve frequently, we can store it in our in-memory cache or maybe Redis cache, so that retrieval could be faster. So why it is important? Performance-wise, I mean to say the faster data retrieval, it improves application response time, reduce database load. As I just mentioned that database query reduction would be there on the server load, and the user experience would also be better, since if we get the data faster, so obviously the user experience is much better. So coming to some of the examples. So let's say I have an example of Instagram and Twitter. When a user visits another user profile on Instagram or on Twitter, right? Now Twitter is X, by the way. So they see the user details, recent post, or maybe some kind of follower count on that user profile. So without caching, what would happen? Every time a profile page is loaded, the app will query the database multiple times to fetch all the information, like like how many posts he has done, what is his follower count, what is his, how much following he or she has. This can slow down the app and increase the load on the database. Since it will increase the load on the database, so the data that would load on your mobile phone or a system will also get, I mean to say, load slowly. So with caching, what will happen? Frequently accessed data. Let's say 2-3 users, person A, person B, or person C are accessing a profile of person D again and again. So these kind of thing, I mean, let's say a person A is trying to troll person D. So data of that particular profile, his follower count or recent post would be stored in cache. In, if you're seeing on mobile, in mobile do also have that cache, it will store over there. This means the data can be quickly retrieved from your cache instead of querying the database again and again. Coming so what are the benefits? Performance improvement, like profile page will load much faster since data is retrieved directly from the cache. Reduced database load, fewer database queries are made, so database and database load would be less on the database, plus it will prevent the slowdown. Enhanced user experience. Obviously, the user experience would be much better if some things are loading faster, and there would be like seamless navigation. Example, like when a user views a popular tweet on Instagram post, the post details are cached. Subsequent views retrieve data from cache only, ensuring a swift user experience and maintaining database performance. By using caching, Instagram and Twitter handle millions of users accessing the same content simultaneously. A smooth and responsive experience for the user. So let's say there is some kind of post that is going viral on Instagram or maybe X, I mean to say Twitter, right? And you are again and again seeing that post, right? That doesn't mean that you are loading it from database all the time. The content of the post would be maybe loaded from your in-memory cache or database, and the view thing, I mean to say, let's say the view increases or likes increases, that can be queried from database, but the other things remain intact and could be retrieved very much faster. So this is kind of a real life example. This is let's say three people, 3 requests are coming on server. So it will deal, I mean all the requests will go to the database and accordingly retrieve the data. So here is a load, right? Now coming to this part, caching part. So let's say 3 requests are coming up to the server. Request 1 will go to the database. Reason being, let's say the request that is going to the database it could not find the appropriate data which was located in cache. So that's why it is hitting the database to like fulfill the request one. But for request 2 and request 3, first it will check in cache. If it is finding that appropriate data in cache, it will retrieve from then and there itself and fulfill the request 2 and 3 for the desired person. So this is how it works. First of all, in our real life code also, like we all are devs, we might be coding in Java, maybe C# or Python, right? So if we have a need to implement this caching, what we will do, we will retrieve those things from cache first. If they are located in cache, then that's good. We need not make a call to the database. Otherwise, we will make a call to the database. And we like declare some kind of constant also in our class files or static content also. Like if a common thing is there. Coming to in industry, what is the importance of this in industry? Scalability. By scalability, like it can handle more users and data by adding more servers, high availability, ensure critical servers stay online. If there is heavy load on the database, obviously services would go down, right? Like health services, they are very much important. Stock markets, military, these are some of the real-time servers. If they go down, a business go down, or some like military servers, they are very much important. So to ensure the critical services, there is an importance of this caching, fault tolerance to maintain operations even if part of the system fails. Coming to some more, like as just mentioned, health services. Hospital needs constant access to patient record. Distributed caching ensure these records are always available. Let's say hospital, there is XYZ hospital, and there are a number of patients in that hospital. Server is down or whatever is there due to some XYZ Z reason. So if the data is available to that hospital for that patient history, patient record, let's say that patient has visited that particular hospital number of times previously for this and that surgeries, right? But and if some kind of surgery needs to be taken urgently, right? So they need to revisit the database to retrieve his history, like whatever, I mean, blood group and what kind of diseases he or she has. But if these kind of things are there in a database and stored in a cache, it would be retrieved very much faster. Stock market, stock prices needs to be updated in real time without delays. So distributed caching helps in providing fast and reliable access. So by distributed caching, we can say the caching is distributed across multiple servers. It's not that only there is just a single server. There could be multiple servers where the data could be stored. And when the data is retrieved from the caches, I mean, the Redis cache or in-memory cache, that is faster, as I mentioned previously. Military system needs to be operational at all the times. So distributed caching ensures data is always accessible, even in case of server failures. So let's say our database is down, I mean to say SQL server or whatever server that we are using, and we have distributed caching. I mean to say number of caching servers are there. So the data would be retrieved from that those caches, showing that server failure, something like that. Coming to type of cache, I just mentioned about like a two type of caches. In-memory cache stores data in the memory of the web server, and it's mostly suitable for single server application or development testing environment. I mean, you can treat it as like when you go inspect on a browser, we have that session storage also, right? There we store session storage. Is there, cookies are there, kind of a cache only, session storage is there, right? So that is in-memory caching. Distributed caching is stores data in shared cache accessible by multiple servers, and it is suitable for scalable, high availability applications and microservices architecture. In an industry, when we work on applications, right? So there we need this Redis cache or maybe memcached. So Redis cache is something that is used mostly for all the microservices architecture type of application and high applications that needs much of the load. Yeah. A distributed cache, coming to this, a distributed cache is type of a cache where data is stored across multiple servers or nodes. These nodes can be in same data center or spread across different data centers around the world. So yes, so let's say I have 2-3 servers or 2-3 or maybe 30 servers of distributed cache. They could be across like different locations also, or in a same data center also. Yeah. Benefits of distributed caching, coming to the scalability part. So the I could say that we can add more servers to handle more data traffic. Let's say in the future, there is a load on even caching also. We are not able to, the cache has also a limit, right? It's not that you can store each and everything. So we can add more servers to handle more data or traffic. If website gets more visitors, more cache servers would be added. High availability explanation part, the data remains available even if some server fails. But let's say some cache servers are also failing, but others are up, right? So yeah, if a server goes down, other servers can still serve the data. Fault tolerance, the system continues to function despite server failures. If a server crashes, data is still accessible from other servers in this case. Coming to caching patterns and policies. So these are some of the caching patterns: cache aside, read through, write back behind, write around, and refresh ahead. So cache aside, so basically the application check the cache first. If the data is not there, it will fetch from the database, store it in cache, and return it to the user. So the next time when a user is querying the same thing, the data would be retrieved from cache. So it is best for read heavy data that doesn't update often. So read through. So the cache checks the database. If data isn't found, store in the cache and return in the user. That's for data that benefits from lazy loading. Write through, data is returned to the cache and database at the same time, keeping both in sync. I mean to say data. Let's say you are inserting a record, right, in database, some employee record. So it would be inserted in cache also and database at the same time. So both are in sync, right? And when you are retrieving that record, directly it would be retrieved from cache if you're querying the same kind of a query. So it is for write heavy applications and needed data consistency for this write through. Write back behind. So data is returned to the cache first and queued for database updates later. So I mean to say we can write the data in cache and we can queue it, and our other operations would work. I mean we will I mean kind of async await. You can consider it like that. It would be queued for database updates. So basically a faster write would be there, and we can do other kind of stuff. So applications which need fast writes with some risk tolerance. I mean, obviously, when you go to the hospital or somewhere in the grocery shop, you don't want that your order completion is taking time or your fulfillment is taking time. So basically, that's why these things are kind of queued. Write around, data is written directly to the database. On read, it fetches from database and stores in the cache. At the first time, like it would read from the database and store in cache. It is best for applications that don't read recent data often. Refresh ahead. So the cache refreshes data before it expires, ensuring the latest data is available when needed. It is best for reducing latency by keeping cache up to date. So cache, like let's say I'm storing some kind of key value in cache, so that also has expiry date. Let's say there is some kind of token or there is some kind of record. I mean to say maybe Jammu to Kanyakumari ticket price is there like 500 rupees, right? And but it is just for 1 month. Maybe after 1 month it would get updated to 600 or something. So they kind of set expiry, and these kind of records have expiry, and it would refresh the data. If it is expired, then the cache would be refreshed. Yes. Some eviction techniques. So how to remove the data from the cache if the cache memory is full. So least recently used, the removes item that are not used for a long time. Let's say in our cache there are number of records or number of data. So which are least recently used, they would be removed if not used. So it like this, we can keep track of items which were last used. When the cache is full, we will remove the item that was used longest time ago. Least frequently used removes the item that have been used least number of times. Let's say there are 100 records, and out of that, one record is people have accessed that particular one record only less number of times. So we will remove that. First in, first out. So basically, the record that will come first will move out. Let's say we can only store 100 records in a cache, right? So now 101 is coming. So the record that was very, I mean, the first in, first out kind of stacking operation. I mean, who will come first? That particular data will move out. So this is first in, first out approach. Last in, first out removes the most recently added item first. So kind of how it works similar. Okay, sorry, that was queue, by the way. I think first in, first out. This was queue, and now this is LIFO. This is stack. Remove the first most recently added item first. Kind of similar to stack only. The last item added. Let's say I have a pile of coins. One coin on the top of that coin, and third coin, fourth coin. Like this, I have 100 coins. Now 101th coin is not getting inserted into database. Reason being, I can only accommodate 100 records. So the top record, I would remove it. So last in, first out. Most recently used removes the item that have been used most recently. It will, how it works, basically it keeps track of when item were last used. If the cache is full, it will remove the item that was used most recently. What is Redis cache? So Redis cache is just a remote dictionary server, kind of like in our Java and C#. If I talk from the code perspective, we store key value parent dictionary or list and we access that, right? You can consider that Redis cache as something like this remote dictionary server, open source in memory data structure, which store data structure store that can be used as a distributed cache, database, and message broker. Basically, it is used to store the frequently used and some static data inside the cache and use and reserve that as per user requirement. There are many data structure present in the Redis, which we are able to use, like list, set. We have used hashing also, hash set we use in Java and our .NET, streaming operations, and many more to store the data. Some of the key features, like in memory storage, data structures, things like it supports string, list, set, sorted set, hashes, persistence options. Data can be saved to disk to prevent data loss. High availability. Redis Sentinel provides high availability through monitoring and failover. So obviously, as I mentioned in my previous slides, that first the data would be retrieved from cache and thereafter a load would go to the database. So if a failover is there, in let's say there are 3-4 cache servers. If one server is failing, I do have 3 up, right? I can retrieve the data from those cache servers. If my cache server, all cache servers are down, or maybe I don't have the data, then obviously I'll go to the database and retrieve my data from database. Then I will give my call to the database. Yeah, scalability. Redis cluster allows horizontal scaling by distributing data across multiple nodes, as we discussed. Benefits: performance, scalability. Performance, like speed is there, low latency, data would be retrieved faster. Scalability, we can scale our Redis server and distribute it across multiple servers. Decoupling, microservices which fetch data from cache instead of hitting the database every time. So there is kind of decoupling. I mean, we don't want to hit database every time. We just want this particular data to be fetched from cache. So like that is decoupling. Availability, I mean failover, if there, then Redis would ensure availability. Replication, data can be replicated to multiple nodes. Now coming to how to set up Redis with .NET. So I mean, we can find it on Google, and we guys nowadays use that Copilot and ChatGPT also. We can find those steps over there, that how to set Redis in .NET. So let's come to the implementation part now. Yeah. So this is just a sample code how to connect to the Redis server. So this is just a sample code. So I just created an object. I will use a namespace of that Redis stack exchange.redis. Then in my sample code, I would connect to the database, Redis database. Currently, I connected to localhost. That's why I have just written localhost over here. And then I would get that database. I would connect to that particular database. So let's come to the basic operations. So implementing cache in .NET Microservices cache site with the pattern where the application first check the cache before querying the database code. So see, how we will get data from cache. Let's say there is some key will come over here. We will set its value. Then we will set its value. Then we'll check if the value is null or something. We'll get it from database and set it in our cache and then return. Next time when we try to, let's say I'm again hitting, next time if I try to get the data, right, I would directly get it from cache. I need not make a database call. So what is the conclusion? I'll come to that demo part, but let me come to the demo part first. This screen is visible. .NET Fiddle, everyone. Can anyone respond? Hello.
Yes, sir. It's visible.
Okay, it's visible. Okay, fine. So see, I have just written a sample program that how do we connect to database. So I'll show you. I just created a free database on this website. I think it's signed out now. So this was the website that I used, redis.io. I created a sample database over here. Coming to the code directly. So this is my sample program. This is my main function. This is how I've connected to database, Redis database. I created, I use a free plan basically, and this is just a username and default password. And this is a database, and this is how I connect to the database. I have some kind of key maybe, and I have some kind of value for that. First, I would check if the key exists in that database. Then if it doesn't exist, what I will do, I'm just doing nothing. I'm just setting it in the database, that particular key, by this method db.stringset. And yes, thereafter I'm retrieving the value. Let me run this particular program. See what it says, key not found in cache. So obviously this is my, this I have built this connection to the database. This is key, this is value. This particular key was not in the database, so it went there and nothing. Key not key not found in cache, and now it has set it to that particular database in Redis. Now this particular key should be there. If I run this program again, see, you guys can see this result, key not found in cache, right? And here now I've like here in this particular method I've set it, this particular key in string set, and here I am retrieving it. Now if I run this program again, see, you see the difference, right? Key found in cache. Now key is there in the cache. In my database server, key is already there. So when I'm checking db.key exists cache key, db is nothing but db is just an object of redis.get database, and it checks key exists. Yes, key do exist, so it's true. Now it goes into the else statement, key found in cache, and it prints this particular record, key found in cache. Yeah. Coming to some more example, let's say one more example I have. Yeah, so this is basically as we discussed just at last regarding the expiry. So I'm setting some key with the name of session user 123. I'm setting this particular key and the value is active. And time span, I'm setting a time span over here. You can see 3 seconds. So this particular key would remain in my Redis cache for 3 seconds. Thereafter, it would expire. So let me run it, run this program. See guys, so here the connection is made, key is there. I'm setting into the database, and I'm checking, with just 3 seconds. And here just a while loop is there. I'm retrieving this time to live for this particular key. Here session, this is, I'm retrieving the key name, and time to live, it would be retrieved as 3 seconds over here. Now this is checking in if condition if that particular key is there or not. So again and again, see, it's what it is printing, TTL for session 123 is 2.921 seconds. So basically it's 3 seconds only. Let me update it, 3 seconds, run. Yeah. So here it is 3 seconds. So what is happening? This particular key, it goes into this if condition. Now my thread is sleeping for 1 second. This is 1000 milliseconds, which is equivalent to 1 second, right? Then again, this while loop runs, it goes into the if condition. Second time statement prints. Again, it goes to the if condition after thread sleeps. Again, it prints. Now 3 seconds are complete because it has printed already printed 3 times. So obviously, I'm just considering, 3 times it is printed. Thereafter, it goes to the else statement. What it prints, session user 123 has expired or does not exist, and we break the loop. All in all, this particular key value pair was there in my Redis database just for 3 seconds, and thereafter it has expired. So these are just few examples that I've just shown that how Redis cache works. Yeah. So coming to this slide. So coming to the conclusion part. So Redis is just a distributed cache, significantly enhances the performance and scalability of .NET microservices by providing fast in-memory data access. It reduces database loads, which we have seen. It improves the response time. It will ensure high availability with features like replication and failover. By integrating Redis with .NET or .NET Core or maybe Java, developers will be able to build efficient, scalable, reliable microservices. And to maximize its benefits, it's very crucial for all of us to follow the best practices like expiry, monitoring, and every. Yeah. So that's it, everyone. Thank you so much.